effects of antibiotics and facilitate movement of resistance to other bacteria, not necessarily even the same species of bacteria. Exposure to antibiotics and to antiseptics, disinfectants, and other biocides thus contributes to the emergence of resistance in bacteria. The wide use of antibiotics has helped shape a microbial world that is composed of many more resistant bacteria than existed before antibiotics were used. Because antibiotics are relatively cheap, accessible, familiar, and generally safe, they are often used casually, indiscriminately, and thoughtlessly. Antibiotics are used to treat humans, but large quantities are also used in food animals, work animals, pets, and plants. Widespread use of antibiotics ultimately reduces their effectiveness for everyone. This leads to a major challenge. How do we apply these life-saving drugs in ways to save lives and also preserve, for as long as possible, their benefits? Too often we are squandering a precious resource. Many global organizations, governments, and institutions are awakening to the serious problem of antibiotic resistance and are trying to find ways to reverse this growing menace. This will not be easy. The effort must be global because antibiotic-resistant bacteria and resistance genes move within regions and around the world with the greatest of ease. They are carried by humans, by animals, in food, and in water systems. They contaminate the soil and water in some areas. Interventions to deal with antibiotic resistance must involve multiple sectors: human and animal health, agriculture, environmental systems, food production, industry, governments, and policymakers. A One Health approach must embrace animal and plant health and the environment as well as human health. Urgent needs include provision of infrastructure to provide clean water and sanitary waste disposal to populations that lack them, delivery of effective vaccines, and research into diagnostics, new vaccines, and new antibiotics and other treatment approaches. Stewardship programs can help to improve use and perhaps allow longer use of existing antibiotics, but stewardship alone will not be sufficient. We also need to reduce the incidence of avoidable infections to reduce the need for antibiotics. 3 prominent areas include improved access to clean water and sanitary waste disposal, increased use of current vaccines, and interventions to reduce healthcare-associated infections. The World Health Organization, WHO, recently delivered a report that lays out total consumption of antibiotics as described by defined daily doses, DDDs, per 1,000 inhabitants per day in metric tons for 65 countries and areas. The consumption ranges from 4.4 DDDs per 1,000 inhabitants in Burundi to 64.4 DDDs for Mongolia. Even within high and middle-income countries, use in 2015 varied widely: 9.78 in the Netherlands, 11.49 in Germany, 14.19 in Japan, 17.05 in Canada, 25.92 in France, and 33.85 for Greece. There is also wide variation in antibiotic use by city and region within countries, including the United States. The marked national variation in use suggests that many countries could achieve good outcomes with substantially reduced consumption of antibiotics. Globally, use of antibiotics can be characterized by excess use in some populations and some sectors, and by lack of access in other low-income populations. Resistant bacteria and resistance genes also spread more rapidly and widely in areas that lack clean drinking water and sanitary waste disposal. In general, low-income countries have higher burdens of infections and have a greater need for antibiotics than high-income countries. Why did I write this book?